Our project on fingertip scanned electrotactile display aims to add another modality to our daily digital life. Thanks to its various advantages over other tactile displays, especially its low power consumption and robustness, it can easily fit on the backside of your phone to let your fingertip actually feel the content you are currently watching. Its biophysical mechanism is driven by a current running through your fingertip skin, and the induced ionic current in your nerve system will give you an illusion of you touching something. By manipulating the frequency, amplitude, and pulse width, we can create illusions of different textures and patterns. And drawing from previous works, we have determined the frequency to be 50 Hz, the amplitude to be 0.6 milliamp, and pulse width to be 10 milliseconds to create the best sensations with minimal pain. And our design is a 2x2 tactile array driven by anodic charge, and it will be placed on your fingertip. Some previous work have used conductive gel to reduce the impedance of our skin, and similarly we have used salt water. In previous work have also proven concentric cathode surrounding an anode is a very good design to create the best sensation, and we have also followed that advice to create a anode electrode inside a hollow cathode plate. Here I present the stimulating circuit for our electrotactile display. As you can see here, there are 4 identical stimulating circuits powered by a common 60-volt power supply in parallel, and the current flowing through all of them is measured by this ammeter. For each pixel, the signal power source turns on and off this transistor. When it is on at 5 volts, current would flow through your hand, simulated here as a 100 kilo ohm resistor. The amperage would be approximately 0.6 milliamp, which is the ideal amperage according to our literature review to generate realistic while not hurtful feeling. And by turning each pixel on and off and designing specific waveforms, we can create complex sensations for our fingertip.
We designed and prototyped an electrotactile haptic display to explore how electrical stimulation can provide tactile feedback through the skin. We began fabrication by using a copper board as electrode base. At the machine shop, we used a hole puncher to precisely cut electrode patterns. The outer diameter of each electrode was 9/32 of an inch, while the inner diameter was 5/32 of an inch. This design allowed us to create discrete contact points for stimulation. Our first prototype was a simple 1x1 electrode tactile user interface. After validating the concept, we scaled up to a 2x2 electrode array, adding an acrylic backing for mechanical support and insulation. For testing, we connected electrode array to a 60-volt power supply. To reduce skin resistance and ensure reliable stimulation, testers dip their fingers in 0.9% saline solution. This concentration mimics physiological conditions and improves electrode conductivity. Users place their fingertip on different electrodes while we control the circuits using an Arduino microcontroller. As voltage was applied, current flows through the finger, typically measured in milliamps, as you can see in the multimeter, generating the distinct tactile sensations.
So the Arduino does its control through the code here, which activates different electrodes by sending 50 Hz electrical pulses through transistors connected to the pins. At the top, I defined the 4 electrode pins, top left, top right, bottom left, and bottom right, along with 1 LED pin. In the setup function, I set all of them as outputs and start the serial monitor so we can print out which electrodes are being activated, which acts as an interface for users to have used to enhance their experience with our product. To help us visualize what's going on, I wrote a helper function pin to grid index. It maps each pin to a position in the 2x2 matrix. This helps us later on when we we'll want to print out the activation map as it indicates the positions on the display. Before we actually send pulses, we use print electrode labels to print which electrodes we're about to simulate, something like top left and bottom left, bottom right. Then we will use the print electrode grid to draw a small 2x2 grid in the console. 1 means here the electrode is active and a 0 means it's off. This is all presented in the 2D array. And the main function that handles the simulation is simulate combo. It takes in any number of pins and sends 50 Hz pulses. That's 10 milliseconds on and 10 milliseconds off for a given amount of time. In the loop function, I go through a few examples here, simulating 1 electrode, then 2 at once, then 3, and finally all 4 together. Each one runs for a second with a short delay in between. It's a good way to test different combinations and make sure everything feels right and fires properly. Overall, this is a flexible test script for our electrode setup. It gives us a clear view of which pin are on and lets us experiment with different spatial patterns.